Hello guys, welcome back to my channel. So today we will discuss about mediator design pattern. So basically mediator design pattern is a behavioral design pattern that reduce or restrict the dependencies between objects, right? So it basically prevent the communication between object rather than we have to communicate via a mediator, right? So I mean, let's take an example. Let's assume that we have an airport, right? And what it is it do? Suppose there is only one runway, right, in this airport, and there is multiple airplane that needs to be land and take off from that same, I mean, same runway. So how will they communicate whether the runway is empty, can I land, or maybe I can take off or not? So so each aeroplane needs to communicate to other aeroplane to confirm whether it is the clearance is okay or not. So it is kind of chaotic, right? So to prevent that and prevent any damages, we have one ATC, air traffic controller, right? So the any communication held for this runway is held with the ATC, right? And ATC is the indirect way to communicate between airplane. ATC maintains the clearance and occupations of this runway. Basically, it takes care of the air traffic, right? So that's where this air ATC is a kind of mediator here, right? So yeah, that's how we this a design pattern plays in real life role. So let's try to take an example, implement it here, and we will get it know in more with details. So let's take a directory mediator. So inside this mediator, we'll take the same example, which is airplane dot h class airplane. Now this airplane will have three functions. First will be, I guess, take off. Okay. The second will be what? Land. Okay. And third will be provide clearance, right? Uh, okay. So this three function is there for, I mean, for airplane, right? Okay, fine. So let's have a more class, which will be nothing but a mediator. Okay. So let's assume we have this mediator. Okay. Now this mediator is what? Okay. So let's take a mediator. Let's first include aeroplane. Okay. Got this. Okay. We have an object, I mean pointer of our airplane. Uh, Fine. So this mediator will provide three function which will take off. Okay, got this. And this takeoff will take one argument. Okay. And before that, I need to check whether this what airplane is not null. Acha, let it be. Let's say if this dot airplane is there, then I'll return simply false. Otherwise, I'll written what? I'll written before returning, I will try to initialize my aeroplane with airplane and return true. Fine. Same will happen with land as well. The same functionality will be for here. And for providing clearance, it does not need any argument, and it will just make this dot airplane null pointer. Okay, fine. So let's make a runway, right? So let's take a commercial. Commercial, which will implement by basically my mediator. Okay. Okay. So commercial will have again three functionality. Before that, I need a mediator object, and I'll have this three functionality over here. And just that I need to I don't need any argument over here. But I need to check whether there is already already runway is occupied or not. So for that I need to check. How I'll check this? So for checking, I can just provide return mediator dot take off, and inside I will put this inaccessible. Let's see. Okay. Okay. So we can make this as the same for others. So let's do one thing. I don't think we need a mediator here. I don't need to implement mediator. Instead, I can implement aeroplane because runway is nothing but implementing aeroplane, not mediator. I don't require ATC here. So aeroplane. Okay. Okay. This is cool. Okay. So we can print something here, right? Let's print something here. If it returning true, that means I'm ready to take off. That's it. Otherwise, I'll try to wait whether that runway is empty for runway to make it empty, right? So I'll try to wait while not equal to. I'll print just waiting. Okay. So the same can be implemented over here for landing. Instead of takeoff, I can have land. Okay. And for providing clearance, I just need to call mediator clear. That's it. Nothing much. Cool. Now we'll have one final class that will be main class. Okay, so inside this, first let's include all other classes. Fine. So let's make first what we should make. So let's make first. I mean aeroplane. What's it? Fine. Now we can provide aeroplane with ATC. I mean mediator. Okay. Well, I think I'm already defining aeroplane over here, so I don't need to provide airplane again, I guess. So what I'll do, uh, I will I will define an object for mediator and commercial, and yeah, because anyway, commercial is implementing my aeroplane, so I'll get the object of airplane. Fine. So let's try to do this later, and commercial, or we can just have plain one mediator. That's it. This okay. We should not have this. Okay. Oh, sorry. Here also object of stack class type commercial is not allowed. Why so? First, we have a virtual object, I mean virtual classes for the take aeroplane. That is correct, right? And this is mediator, which is having I mean everything. Let's initialize this with null pointer. Anyway, by default it will be null pointer, but still make it null pointer. We don't need to require a bit. Okay, so I think everything is right. This aeroplane is a null pointer and false otherwise. Okay, okay, got it. Fine, fine. I guess everything is okay here. Okay, okay, okay. Spelling is wrong, but nothing to worry. Uh, cool. So let's move on to commercial and in commercial, I guess, right? Right. Okay, so let's do one thing. Let's initialize commercial. Okay, we have not provided constructor, so we can initialize, I mean, mediator because here we are providing mediator inside our commercial, right? So we need to provide that. So that's what the error is actually. Okay, I think it should be right. There should no mistake. Okay, so why this pure virtual function has no override? Do I need to provide override? I don't think so. We're just implementing, not overriding. So do one thing. Okay, okay. So see, the thing is here, as I can see, I have used aeroplane. I have provided argument, but it is not required. That's why I was showing an error here. So let's try to have another plane. Now I will try to take plane one, take off. Okay. Oh, sorry. I have no pointer. I just can use dot plane two dot take off also. Let's see what happens. Okay. Let's try to compile this code, and before that, I need to provide pragma once. Okay. Let's see. Waiting. Obviously, it will show waiting. Why so? Because first time I have used plain dot takeoff, right? Then what happens? It came here, and it just check whether I can I can take off or not. I right. So for that, it will provide this as an argument and parameter here, and it will take argument as aeroplane, and it will first check whether there is a null pointer for this aeroplane or not. First time it will it gets that there is null. That's why it will define the aeroplane with my given aeroplane in the argument and return true. This is for the first time. Again, I have used plane to dot takeoff. So it will again pass here takeoff, and it will check whether the mediator takeoff is returning true or false. And as I can see here, aeroplane is not null pointer, is not null. So it will return false. So coming here, it will return false. It will go to this while loop, and it will try to again do takeoff until we get clearance. I mean, if there is a clear or not, and it will print waiting continuously. What if I provide clearance before taking plane take off for the plane two? So let's provide clear of plane. Then let's see what happens. And as expected, it should print both takeoff for the plane one and plane two. Let's see this. Right, ready to take off and ready to take off again. So both plane are taking off as I provided clearance by plane one. That's why. So this was your mediator design pattern, and I hope you liked and learned this mediator design pattern. And see you next time.